All right, we're going to do problem number 23 now. And in this one, we're hanging a cat and a dog. Not a live cat and dog, sorry. They're metal representations. It's a mobile or something like that in an art museum. So there's a cat suspended here, dog here. There's a wire that comes down here at a 20-degree angle, a wire that connects them, and then a wire that goes up here, angle we don't know. What we want to do is figure out the tensions in all these wires. So this one we're going to call tension 1, this one. This one is tension 2, connects these two together here, and then there's going to be a T3 up here. Yeah? And so what we need to do to figure this out is we start same way we always start, we have to do a free body diagram. So I'm going to do a free body diagram for the cat. So in this case, we have the one coming down here, that's just the mass of the cat. Now, it's in equilibrium, so that's the mass of the cat times gravity. There's no acceleration, it's just hanging there. Okay, then we have tension 1 going out this way at an angle of 20 degrees, and we're going to call this tension 2 going this way. Okay. Now, same thing, I'm going to set up my axes this way, and I have to take my components of T1, and so if I drop this down, this becomes T1 cosine 20 degrees, and then this one becomes T1 sine of 20 degrees. Okay, now let's do a free body diagram for the dog. For the dog, we have the mass of the dog, which is more than the cat, times gravity. We have tension 3 here at some unknown angle. And then we have tension 2 going back this way. I'm going to do my free body diagram the same way. Just like this. T2, tension here should equal the tension here. Okay? For T2 only. So really I'm doing the free body diagram of the two knots here where they all connect together, where the two ropes connect together. I have to do the components of this one. This is T3 cosine theta. This is T3 sine theta this way. All right, and now we're going to do step 3, which is F net x. So for the cat, so I'm working off of this one, I got F net x is going to be equal to T2 minus T1 cosine 20 degrees. Okay? And for F net y, I'm going to have T1 sine of 20 degrees minus the mass of the cat times gravity. Well, look at this. Both of these are 0 because it's in equilibrium. So I can move this to this side and get the mass of the cat times gravity is equal to T1 sine of 20 degrees. And so I can now solve this for T1. So T1 is going to be mcg over the sine of 20 degrees. And when I do that, I know the mass of the cat is 2 kilograms times 9.8 divided by the sine of 20 degrees. I get T1 is equal to 57.3 newtons. So I figured out the tension in rope 1. All right, but now that I know T1, look, I can go back into here and figure out what T2 is. So I'm going to go back to this equation. Right here, I'm going to solve this for T2. So I'm going to get T2 is equal to T1 cosine of 20 degrees. All I did was move that to the other side since this is equal to 0. So T2 is equal to 57.3 times cosine of 20 degrees. Or tension 2 is equal to 53.8 newtons. So I got T1 and T2. Now to get to T3 and the angle over here, we're going to have to use the dog. So now we're going to do the dog over here. Notice these problems take a lot of room. You're kind of doing about one problem per page because there's a lot to go here. Always show all your work and all your steps. When I grade your tests, I look to see if I can follow your steps. If there's none of these steps and you just have an answer down here, I will usually count it wrong even if it's the right answer. Because all I care about is how did you get there. I care a lot more about that than what your actual answer is. So get used to the steps. I want to see all the steps. So for the dog, I'm going to do f net x. And f net x is equal to T3 cosine theta minus T2. And now this is equal to 0. I can set this over here and say, oh, well, T2 is equal to T3 cosine theta. But I still can't solve that. Even though I know T2, I don't know T3 and I don't know theta. So I have two unknowns still, so I'm kind of stuck there. So let's go to f net y. F net y for the dog, we have T3 sine theta minus mass of the dog times gravity. This is 0. So we can move this over here and we say, oh, the mass of the dog times gravity is equal to T3 sine theta. So now I have two equations and two unknowns. Right? I know this stuff, I know this side, but I don't know T3, I don't know sine theta. The easiest thing to do here, the way I like to do it, there's several ways to do it. You could solve this for T3 and plug it in, or I just divide one equation by the other. So you see this equation here, I'm going to put this underneath and say T2 is equal to T3 cosine theta. And I'm just going to take this equation divided by this equation. Since those are equal to the other, it's like dividing both sides of the equation by the same thing. The good thing is when you do that, I get mdg over T2 is equal to, and notice that T3's cancel, and sine of cosine over cosine is tangent of theta. Now, I've eliminated all the variables except theta, and so I can say theta is equal to the inverse tangent of the mass of the dog times gravity over T2. Or theta is equal to the inverse tangent of 4 times 9.8 divided by T2, which I have is 53.8 newtons. And I get my angle theta is equal to 36 degrees. And then once I have theta, I just plug it back into here, solve for T3. I can say, oh, well, T3 is going to be equal to T2 over the cosine of theta, or in our case, T2 is 53.8 divided by the cosine of 36 degrees, and you get that T3 is equal to 66.5 newtons. And there we go. That's how you do these problems. Okay.